Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of Leetcode Weekly Contest 305. It's a medium level problem. The problem name is Reachable Nodes with Restrictions. So we are given an undirected tree with n nodes labeled from 0 to n minus 1 and n minus 1 edges. Yeah, so our typical tree. Also, we are given a 2D integer array edges of length n minus 1 where edges of I equals to ai comma bi. That indicates that there is an edge between nodes ai and bi in the tree. You are also given an integer array restricted which represents restricted nodes in our tree, right? So this is also given. So we need to return the maximum number of nodes that we can reach from node 0 without visiting a restricted node. Note that node 0 will not be a restricted node, right? So this is the graph, this is the tree that we are given. So we can see we have certain edges, and the node in the diagram, the node represented by green color are the reachable nodes, and also node number 4 and 5 are restricted. So obviously, since so if I take example of node number 5, since it is restricted, so you can't visit that node, so therefore you can't visit node number 6 as well, right? So no restricted node should come in the path of any node, right? Simple thing. I would say it's a typical DFS problem. Just testing whether how fast you can write the DFS code. I'll try to explain you with the help of a diagram so that you understand the problem. So this is the tree that we have: 0, 1, 2, 3. Then we have 4. Actually, that is not directed. I just made it. It is not directed, undirected, obviously. Then you have 5. Then you have 6, right? And you have certain restricted nodes here in case 4 and 5. So what we do, we first construct the adjacency list for this one. So how will that look like? It will look like something like 0 is connected to 1, 4 and 5, right? What about 1? 1 is connected to 0, 2 and 3. 2 is connected to 1. 3 is connected to 1. 4 is connected to 0. 5 is connected to 0 and 6. And so on. 6 is connected to 5. You construct a adjacency list and you just perform a DFS from node number 0, right? Now what we do in DFS, right? We do not want to visit a node more than once. So while you are at this node, just see what are the adjacent nodes. So here we have 1, 4 and 5. Now if the node that you are gonna visit is already visited, right, is already visited or is a restricted node, don't do DFS on that node. Else, if these two conditions are not satisfied, that means it is not visited and is also not a restricted node, just apply DFS on that, right? And obviously when you do DFS, just increment the count and we are good to go. Nothing complicated. Let's directly jump into the code. So yeah, this on line number 35 I've called a function construct the adjacency list, and here you can see on line number 2, 3 and 4 I've taken again a couple of sets and a map. The map will basically represent the list, the adjacency list, where integer the key is the node and the list of integers are the neighbors for that particular node, right? So on line number 5 we have the function. What I'm doing is for each I am beforehand only I'm pushing a new array list just to make the code less complicated. Otherwise while inserting, if that value is not present in the map, I'll have to construct a new list and all that. So that is why I've just skipped that. And then we traverse the edges and then we are making the adjacency list, right? Line number 12 and 13, node 1 is this, node 2 is this. Fetch the list for node number 1, add n2 in that, again update the list and so on, right? So you on line number 35 you have that, and then on line number 37 what I've done, I've added all the nodes, restricted nodes in a set. Now this is just to simplify the check in our DFS. That's it, so that I can directly check in O1 whether a particular node is present in restricted node or not. That's why an array was given, I have transformed that into a set. Now I just do DFS of 0 and return visited.size. Let's come to the DFS code. So on line number 23 the DFS code starts from current node and that value is 0, right? So we add the current node to the visited set. Now we see what are the neighboring nodes, right? So you can see we have started traversing, and on line number 27 we are checking that if the neighboring node, current neighboring node, since we are traversing the list, right, if that is already visited, or that is present in the restricted list, or that is a restricted node, then just skip it. Don't do DFS. Else just do DFS of on the ith node, right? And we are good to go. Now you can see we are every time we are adding a valid node in the visited set. So that is why on line number 41 we are returning visited dot size, and will be good to go. We'll get the total number of nodes that can be reached from 0. Also, if we look into the problem statement, so you can see that starting from 0 is also reachable, right? So you include that into the answer. Hence we are returning visited dot size, or else we would have returned visited of size -1. But yeah, that's just an observation in the problem, right? So yeah, hope you learned something new from this video, testing your DFS knowledge. Do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries, do mention that into the comments. I'll try to resolve each one of them. Thank you. Take care. Bye bye.